Yeah, hello everyone. So in this video series, I am going to discuss about entire concept of complex analysis. So first topic I have taken partial derivative, and then I will teach continuity, and then I will move to analytic function and differentiability. What is differentiability in complex? So first, let me discuss about partial derivative. So we know that partial derivative, if u is a function of x, y, if u is a function of x, y. So what is meaning of dou u by dou x at a comma b, and what is meaning of dou u by dou y at a comma b? So partial derivative dou u by dou x at a comma b is defined as u a plus h comma b minus u a comma b by h, and dou u by dou y is defined as limit k tending to 0 u a comma b plus k minus u a comma b. So if you will see here carefully, what is meaning of partial derivative? So when we are differentiating with respect to x, so you are looking here, changing this first component a plus h and here ua. So if you will look at here, the changing is happening only along x direction in the first component. If you will look at here, so a plus h and a. So here this first component, x component, is changing from a plus h to a, while y component remains same. It is from b to b. So dou u by dou x means changing will happen only along x direction. And dou u by dou y, if you will see here, first component x remains same and y is changing from b plus k to b. So in dou u by dou y, changing will be happening along only y direction. So dou u by dou x changing along x direction, and dou u by dou y means changing along y direction. So let me explain some example. For example, if you are having this kind of function, let me first example u of x y. Let me explain. U of x y equal to x y by x square plus y square if x comma y not equal to 0 comma 0 and 0 when x and y are 0. So our function is divided into two parts. U of x y is given, and x y by x square plus y square when x y not equal to 0 and when x y 0 0, value of function given 0, and we have to calculate dou u by dou x at 0 comma 0 and dou u by dou y also at 0 comma 0. So how to calculate? So here a and b are given 0 0. If you will look at here, a comma b, what is a comma b in the formula? A comma b is at what point we want to calculate partial derivative. So here a and b are given 0 0. So simply we can write dou u by dou x at 0 comma 0. So here a and b 0. So now we can use the formula limit s tending to 0 u of a plus h. So a is given 0, so you will get u h comma 0 minus u 0 0. Here if you can see here, value of the function at 0 comma 0 is defined as 0. So u 0 0 is given 0 and divided by here h. So this equal to limit h tending to 0 u h comma 0 you can calculate, because here u of x y is defined as x y by x square plus y square. So h comma 0 means x component h and y component 0. So you will get here 0 u h comma 0 and minus u 0 is 0. So divided by h, and this limit is what? 0. So some students, they might have problem that here y, if h is tending to 0, then this limit is like 0 by 0 and infinite. This is not true, because this limit will applied once we can calculate this resultant. So here u0 0 0, u h comma 0 is 0, u0 0 is 0, and something divided by 0 is what? 0. So here we are, because here h is tending to 0, h is not exactly 0. If h was exactly 0, then only we can say that this is 0 by 0. But here h is tending to 0 and something divided by 0 is 0. So don't get confusion that here 0 by 0. Because if I will remove here, if I will remove this limit from here, now if I am asking what is this value 0 minus 0 by h, then simply you can answer 0, and after that then limit will work. So here you don't get confusion that this is 0 by 0. This is limit h tending to 0. So first derivative dou u by dou x we are getting 0. Simply we can calculate dou u by dou y at 0 comma 0. This will be what? Dou u by dou y at 0 comma 0. This equal to limit k tending to 0 u of, now a and b 0, so you will get here 0 comma k minus u 0 0 and divided by k. So this equal to, again because x our function u of x y is given x into y, so if x is 0, then you will get again this limit is also 0. Limit k tending to 0 u0k, you can calculate, you will get 0 by k square, and 0 by something is what? 0. u0 0 is 0 by k. So this limit also we are getting 0. So dou u by dou x is also 0, and dou u by dou y at 0 comma 0 is also 0. Next example, second example, we can consider u of x y equal to x cube minus y cube, x cube plus y cube divided by x square plus y square, and here xy is not equal to 0 comma 0, and value of function is 0 when x and y both are 0. So again we can calculate dou u by dou x and dou u by dou y at 0 comma 0. So dou u by dou x 0 comma 0, you can calculate at any point 1 2 2 3 3 4, any point you can calculate, but for easy calculation only I am taking here 0 comma 0. You can calculate at any point by putting values of a and b. This is 0 comma 0. So again we can apply same formula, changing along x direction and changing along y direction. Dou u by dou x. So dou u by dou x, dou u by dou x at 0 comma 0. This will be what? Limit h tending to 0 and u h comma 0. So let me write here formula properly. U a and b 0, so h comma 0 minus u0 0 divided by h. So this equal to, what will be value of u h comma 0? Simply we can calculate. So here u of x y is given x square x cube plus y cube by x square plus y square. If I will ask what is value of u h comma 0, h comma 0 means x component h and y component 0. So you will get h cube by h square, which is equal to h. So this limit h tending to 0, limit h tends to 0, u of h comma 0 is h minus u0 0 as it is given 0 and divided by h. So this is equal to what? 1. And similarly dou u by dou y changing along y direction, 0, 0. This equal to limit k tending to 0, u0 comma k, u0 comma k minus u0 0 and divided by k. Don't get confusion by h and k. Actually, this is just a different name. Along x direction, we are changing. We are taking h as a change, and in y direction, we have taken k as a change. So this is same. You can take same also. So u0 comma k will be what? Limit k tends to 0. u0 comma k. Similarly, you can calculate because x cube plus y cube by x square plus y square. So 0 k x component 0. So you will get k cube by k square. This is equal to k. So k minus 0 divided by k. So this is equal to what? So dou u by dou x and dou u by dou y we are getting 1 and 1 at 0 comma 0. So let me third example. Let me take u of x y. Suppose this is given x square plus y square plus e power x, and we have to calculate dou u by dou x at 0 comma 0 and dou u by dou y at 0 comma 0. So what you will get? Dou u by dou x. Simply you can differentiate. So dou u by dou x. What will be dou u by dou x? Differentiation of x square we know 2x. Differentiation of y square with respect to x 0. Differentiation of e power x is e power x. So dou u by dou x at 0 comma 0. This equal to x value 0 and here x is also 0. This is plus. So 2 into 0 0 and 0 plus. So you will get here 1. Similarly, you can calculate dou u by dou y. What will be dou u by dou y? X square 0, y square you will get 2y and e power x 0. So dou u by dou y at 0 comma 0, this will be 0. So dou u by dou y at 0 comma 0, so this will be 0. So now here question arise here. In the first two problem, I have solved the question by applying definition, but here I have just differentiated the function and just I have put the values of a and b. So what is difference here? When we will use that definition of partial derivative dou u by dou x at a comma b, and when we can directly differentiate. So this type of question we are facing, that why sometime we are differentiating, why sometime we are using that by formula. So here is the answer, because if you will look at these problems, u of xy by x square plus y square. Simple reason why I am not differentiating this function, because this question also can be done by direct differentiation. These both are same. Either we can apply uh, formula dou u by dou x at a comma b and dou u by dou y at a comma b. Either we can direct differentiate the function and we can get u0 0. But in which case you will use the formula. So here if you will look at here, if I am asking what is value of u0 0. So here x y is, one more time, let me write here. So this is given our first function u of x y. This was x y by x square plus y square. So what is value of here u0 0? If I am going to ask you what is u0 0, so here you will get 0 by 0, which is undefined. So because of that, we are using, if you are having any rational function like f by z, if you are having any rational function f and z, where f is also not defined at 0 comma 0 and u is also not defined at 0 comma 0. So in that case, we have to apply the basic definition of partial derivative. And when if you will look at here, our third example, if I am taking this simple example u of x y equal to some polynomial or some trigonometrical function or exponential function sin x plus x square plus y square. So here if any in this question also we can solve by using the basic definition of partial derivative. But here you can calculate directly dou u by dou x. Dou u by dou x is what? Dou u by dou x sin x differentiation cos x and x square differentiation 2x and y square differentiation 0. So we can calculate dou u by dou x at 0 comma 0. So why I am direct differentiating the function? Because here in this question u0 and 0 is defined. In this question, if I am asking what is value of u0 0, sin 0 0, x square 0, y square 0, so we can get 0. So this is defined. But in that question, what I have taken beginning two question, dou u by x square plus y square or x cube plus y cube by x square plus y square. In both the question, u0 0 was not defined. So because of that, we have applied basic definition of partial derivative. So this is simple meaning. Many students, they are having doubt when we have to differentiate and when we have to use uh, basic formula for partial derivative. So in that case, if u0 0 is defined, then we can differentiate directly. Otherwise, we can use the by using formula we can solve. Next, now what is the continuous function in two variable? Because in this video I am going to discuss about partial derivative and continuity. So what is continuous function? So what is continuous function? Just I am going to write definition. A function, because I am going to discuss in two variable. And why we are studying these concept? Because we know that when I will start main syllabus, in that time we need CR equation, we need differentiability, then we need analytic function. So for discussing these concept, it is mandatory that our continuity and partial derivative concepts should be cleared properly. Then only we are able to understand in CR equation, because CR equation is just component of partial derivative, and differentiability also we need to check. But if function is not continuous, then we are not able to check differentiability. So because of that, these concept we need to be cleared. So what is continuous function? We know that if you are having a function, two variable function fxy, is said to be continuous at a comma b. Continuous, simply I am writing at a comma b, this function is said to be continuous at a comma b if limit x tending to a and y tending to b fxy, this must be equal to what? F of a comma b. So this is basic definition of continuity. If you are having this is if you remind, if you know, if you remember a continuity definition in one variable. So limit x tending to c fx equal to f of c, but here we are discussing in two variable at a comma b. So limit x tending to a, y tending to b fxy, this must be equal to f of ab. Next concept, which is more important. Here I have written limit. So what is difference between limit in one variable and limit in two variable? So let me discuss here properly. Consider this is what? X-axis. This is what? Y-axis. And suppose we are having some function here, f of x. And we have to discuss limit at x equal to c. So in one variable, if you remember, so if you have to check continuity at x equal to so there are two paths only. Either we can approach from right side or we can approach from left hand side, and we know also that this point, left hand side point, is known as x minus c, and right hand point is known as x plus c. Yeah, so let me use a different color. So this is what x plus c. This is what x minus c. A point before x, and this is what x plus c. And this is also known as right hand limit and left hand limit. So in one variable only we are having two paths. Either we can approach from left hand side or we can approach from right hand side. But if you will see limit in two variable, there is a different scenario. So in two variable, actually suppose this is what? This is a two variable function. This is considered a function fxy. Just simply I have taken. And this is a plane, like plane. This is not like only boundary we are having. This is considered. So this function we are having, and if you have to check limit at 0 comma 0, because now this is a like a plane. So if you have to calculate limit at 0 comma 0, so how many path we are having? How many path we are having? Infinitely many path. In one variable we are having only two path, but in two variable we are having infinitely many path. So this is difference. Either you can approach from this side along the positive x-axis, either you can approach from negative x-axis, either you can approach from this line, either this is this line, let us may assume that y equal to x, either you can approach from this parabola y equal to x square, either we can approach y equal to x line, this line, this line, this line, this line. So what we are observing that limit in one variable and limit in two variable, what is basic difference? Limit in one variable only we are having two direction, but limit in one variable only there are two direction. But when we are going to discuss about continuity in two variable, we are having infinitely many ways. So this is basic difference between limit in one variable and two variable. So how you will check continuity in two variable? Simple example I am going to take, and then I will tell is there any connection between partial derivative and continuity. So one imply other or no one implying to each other. So what is connection between partial derivative and continuity? I will explain. But first, let me explain some example. Suppose if you are having this example fxy, this equal to xy by x square plus y square. Same example I am taking which I have taken for partial derivative. So this is what? X square plus y square when xy not equal to 0 comma 0 and 0, both x and y are 0 0. So how to check continuity of this function? Actually, because I am going to discuss in two variable. So in two variable, we know that for existing of continuity function, limit should be unique, and this must be equal to value of function. So let me check limit of this function about some direction in along some direction. If I am choosing along first path, I am choosing along x direction. So only I am choosing path along x direction. So we know that along x direction y should be what? 0. So what we get? So this we can get limit x tending to 0 and y. What about y? Y cannot tend to 0 because here we are checking along x direction. So along x direction y is not changing tending to 0, y is exactly 0. So limit x tending to 0 will be what? 0, because y is 0, 0 into x divided by x square plus y square is 0, so x square plus 0. So what will be this limit? So 0 divided by something, again we are getting 0. Similarly, we can choose limit along x direction. Along x direction we have taken. Now let me take along y direction. Along y direction. So along y direction, x will be what? Completely 0. So you will get limit k tending to 0. Sorry, limit y tending to 0. Limit y tending to 0. And fxy is given xy. So because x is 0, so you will get 0 into y divided by x square plus y square. So x is 0, so 0 plus y square, which is equal to 0. So along x direction we are getting limit 0, along y direction we are getting limit 0. So what we can conclude, this function is continuous or not continuous, because we are getting unique limit along two direction. Now let me take third path along y equal to x direction. Now this path will make difference along y equal to x direction. So why I am choosing along y equal to x direction, and why we cannot take along y equal to x plus 1 or x square plus 2? This path we cannot take, because if x is tending to 0, then y must be tending to 0. Then only we have to take those path. When we are taking x tending to 0, then y should be tend 0. But if I am taking y equal to x plus 1, y equal to x square plus 1, so these path cannot be taken. Why? Because if x 0, then y has to be 0, because we are checking limit at x 0 comma 0. When we are checking limit at 0 comma 0, so if x is tending to 0, then y also has to be tending 0, then only that path is suitable. Otherwise we are not able to choose that part. If anyone is asking why x plus 1 is not taken path, so because y equal to x plus 1 we cannot take, because if I will draw the line y equal to x plus 1, y equal to x plus 1, if you are thinking that y equal to x plus 1 is not taken, so this line you can find here, this is x equal to minus 1 comma 0, and this is 0 comma 1. So this line will pass through this minus 1 comma 0 and 0 comma 1. What about 0 comma 0? So only we can choose those path at which is passing through the origin. For example, are we allowed to take y equal to x? Yes. Y equal to x square, x, yes. Y equal to x cube, yes. Y equal to x power 4, yes, we are able to take. So only we can take those path which is passing through the origin. And just we are because in this question they have asked about continuity, just we are checking limit. If limits are different along different path, then we are done. We can conclude that this function is, limit of this function does not exist, so function is not continuous. That is only I am trying to prove that. So along y equal to x direction, what will be limit? Along x equal to x direction, so limit x tending to 0. Now y we have taken x, so x into x square, and divided by 2x square, which is equal to what? 1 by 2. 1 by 2 is not equal to 0. So we can say fxy is not continuous at 0 comma 0. fxy is not continuous at 0 comma 0. Why? Because limits are different along different direction. Limits are different along different direction. So this function is not continuous. Now many students they are having doubt that how many path we can choose. How many path? Because in two variable there are infinitely many path. So how we should know that whether function is continuous or discontinuous? So because of that, if you will see in two variable continuity and discontinuity function, it is clearly mentioned that prove that this function is discontinuous or this function is continuous. So students also having doubt that if I am choosing 3, 4, 5, 10 path, and along all the path we are getting limit 0, so can we make sure that this function is continuous? No, because this is wrong way. We are not able to take infinitely many path. So this concept, what I am using here, this is only for discard. Only if you want to prove that function is discontinuous, then only we can use this method. If we have to prove that this function is continuous, then only one method you have to apply, which is known as epsilon delta method. Epsilon delta method is only eligible to prove that function is continuous or discontinuous. But here, because we are interested that discontinuity of the function, if you are choosing different path and limits are different, then we can conclude that function is discontinuous. Now you can ask how I did get idea that along y equal to x, I am going to get different path. How I get to know that this y equal to x will make difference? Why I get to know that? Because if I will ask you what is power of numerator of this function, x power 1 and y power 1, so you will answer 2. And what is power of denominator, x square plus y square? This is degree of denominator and numerator, both are 2. So by what path we can choose so that power of numerator and power of denominator always remain same. So you can say y equal to x. If I am taking y equal to x square, again you are going to get limit 0. If I am taking y equal to x cube, again you are going to get limit 0. So because of that only, because we know that limit of a function is finite if power of numerator and denominator same. If power of numerator is more, you will get limit 0. If power of denominator is more, you are going to get limit infinite. So just because in along two direction we are getting limit 0. So because of that I have taken y equal to x, because y equal to x if I will take, then power of numerator and denominator must be same. So always in question, if you are given that prove that this function is discontinuous, then always you have to apply this kind of method. We can choose different limit. Next question. If you are having second question, fxy equal to x square plus y square when xy is not equal to 0 comma 0, and when this is 0, xy both are 0 comma 0. So what you can say about this function, continuous or discontinuous? So because this is polynomial type, so simply we can apply the definition limit x tending to 0, y tending to 0, fxy is equal to limit x tending to 0, y tending to 0. This is what x square plus y square. So this equal to 0 plus 0, which is 0. And 0 is also, you are observing 0 is also value of the function given. So this function we can conclude that this function continuous. So if you are getting a simple polynomial type question, then simply you can apply the definition. But if you are getting like rational function x square, y square, something like that, then always those type of functions we can check only by path test, which is also known as non-existence of path test. According to this method, we have to choose different path, and we can prove that function is continuous or discontinuous. But if you have to prove that function continuity, then only we have to use epsilon delta method. And you are aware with because this we are making this video based on only engineering, so this epsilon delta method is not required. If this was some other classes like BSc and MSc, then epsilon delta definition was needed. But for engineering, only we need to understand how we can prove that limit of the function exists or does not exist. Next, now I am going to explain, is there any connection between partial derivative and continuity? Whether partial derivative is implying continuity or continuity implying partial derivative. So let me give you simple example. Then answer of this question, you will get to know that, because some student they might have a problem that if partial derivative existing, so partial derivative here it doesn't mean that you are checking differentiability. Differentiability is what? Differentiability function should be differentiable means we should get unique tangent if I am discussing in one variable. and unique tangent plane if I am discussing in two variable. So if partial derivative and if you are connecting partial derivative to differentiability, then we are approaching in wrong direction, because partial derivative is only along x direction and along y direction. So partial derivative and continuity, I want to know that is there any connection. So let's see fxy. Let me first example fxy equal to fxy equal to, if I am choosing here y plus mod x if xy not equal to 0 comma 0, and here 0 if xy 0. And now I am going to ask you, because there is no doubt that this function is continuous, because you can see here mod x is always continuous function and y is also polynomial, so always continuous, and addition of these two function also continuous, and value of function also you are observing here 0. So this function, because f0 0 is also 0, and if this is not given 0 also, you can observe that mod x is everywhere differentiable, continuous, not differentiable. Mod x is everywhere continuous and y is also continuous. So now let me check partial derivative of this function. Partial derivative is what? Dou f by dou x. Dou f by dou x will be what? So because here mod x we can define, so this function we can take here. One more minute, let me define here properly. So fxy we can define in more generalized form, y plus x if x is greater than 0, greater or equal to 0, and y minus x if x is less than 0. Now we can calculate dou f by dou x and dou f by dou y. So let me calculate first dou f by dou x. What will be dou f by dou x? Dou f by dou x will be what? So differentiation of y with respect to x, you know 0, and you will get here 1. If x is greater than 0, greater or equal to 0, you can remove equality sign or you can include. And here we are getting minus 1 if x is less than 0. So here you can observe that because dou f by dou x along, if x is greater than 0, then we are getting here 1 and here minus 1. So we are getting two different type of derivative. So what we can say that dou f by dou x does not exist. Why does not exist? Because we are getting two different limit, 1 and if x is greater than 0, 1, and if x is less than, then minus 1. So you can observe that this function is continuous, but partial derivative of this function does not exist. So we got idea that partial derivative, sorry, continuity does not imply partial derivative, because this function, if you look at here, this function was continuous and partial derivative does not exist. What if if function is discontinuous, then what we can say? Then again there is no connection. I will give one example. If function is discontinuous, then what you can say about its partial derivative? Second example. Second example, if I will take f of x y equal to 1 if x y not equal to 0 comma 0, and here 0 if x and y both are given 0 comma 0. So what you can say about this function? This function is continuous or discontinuous? Obviously, this is discontinuous because value of the function is given 0 and here function is defined 1. So value of function is not equal to its limit. If you will calculate limit x tending to 0, y tending to 0, So you will get here 0 cannot be equal to 1. But what about its partial derivative? So what will be dou f by dou x? So you are looking here, if I will differentiate the function with respect to x partially, so dou f by dou x, this is also because differentiation of 1 is what? Differentiation of this 1 is what? 0, and 0 is 0. So dou f by dou x is also 0, and dou f by dou y is also 0. So you are looking here, we are getting some magic type here when we have taken function discontinuous, then partial derivative was not existing, and here I have taken function discontinuous and then partial derivative existing. So there is no connection between continuity and partial derivative. Continuity here does not imply partial derivative, and even though discontinuous function if you are having, maybe those functions partial derivative will be existing. So we cannot say any that if a function is continuous then partial derivative will exist or does not exist. Same thing, if a function partial derivative exists, then what we can say about continuity? Let me give again another example. If you are having this function fxy equal to, if we are having this function f of xy equal to, this example already I explained, but one more time, just xy divided by x square plus y square when xy not equal to 0 comma 0, and here 0 if xy 0 0. So in this question already we have seen that, already we have calculated dou f by dou x at 0 comma 0, this was also 0, and dou f by dou y at 0 comma 0, this was also 0. So we can make sure that we can ensure that limit partial derivative of this function existing, both dou f by dou x and dou f by dou y. But also we have seen that this function fxy is not continuous. Why this is not continuous? Yeah, before some time I explained, because along x-axis limit 0, along y-axis limit 0, and along y equal to x, we are getting limit 1 by 2. So by using path test, we can make sure that limit does not exist. So function is, if limit does not exist, then we can make sure that function cannot be continuous. So this example is showing that partial derivative of this function at 0 comma 0 exists, but function is not continuous. So just you should clear your concept in proper way. Continuity and partial derivative does not imply each other in case of two variable function, because here partial derivative is not like differentiable function. Differentiability is too much different from this partial derivative. So I hope this partial derivative and continuity concept cleared. In next video, I am going to take some more example of this path test. And also in next video, I will discuss about CR equation, differentiability and analytic function. Thanks and keep watching.